Okay, 3.2, we're split it up into 2 different days. We're going to start talking about sine, cosine, and tangent. Bless you. There's a lot of vocabulary that you need to be really comfortable with by the time the test rolls around. Okay. So today's lesson is all about kind of angles, and some vocabulary here is, let's talk about what it means for an angle to be in standard position, because that's in a lot of the test problems. It'll say this angle is in standard position with its terminal ray here, and you've got to know what all of that means. It says, definition 1, standard position. In the coordinate plane, an angle is in standard position when its vertex is at the origin, and one ray of the angle lies on the positive x-axis. So here you've got that in your picture. And then a terminal ray, that's just where the angle terminates. It's where the angle stops. That's how you can remember that. So that's clearly labeled in the picture. So here we have this obtuse angle. Here is the terminal ray right here. And then I want you to know something extra that I noticed shows up on the test. We just created the test this morning, so let me give you some insight. You guys, if you're on your phones, I don't know how you're going to learn this stuff. I really don't. That arc right there, that arc is called a subtended arc. It's the arc that's created when we draw a circle. It's the part of the circle that's created by this angle in standard position. It's called the subtended arc. Okay. Now let's talk about sine, cosine, and tangent. Given an angle in standard position and a circle centered at the origin, just look at the picture. Here's point P. What quadrant is point P in? Quadrant 1. And all of the coordinates in quadrant 1 are what? Positive, negative, what are they? Positive, positive, right? While we're talking about that, let's just kind of go around here. Here's quadrant 2. All of the x values in quadrant 2 are what? Look at where the x-axis is. Okay, negative x, positive y. What about quadrant 3 down here? Negative, negative. And then what about quadrant 4? Positive, negative. Now those are some things that they kind of just, the creator of these notes just kind of thought, surely they'll remember that stuff. So I just want to pause and make sure you kind of remember ordered pairs in the quadrants. That's going to help, that kind of stuff will help you a lot, okay? Here's the definition of what sine of theta is. This symbol right here, theta, that just means an angle measure, an unknown angle measure. Sine theta is the ratio, aka fraction, of the vertical displacement of P from the x-axis to the distance between the origin and point P. Okay, to me, in my opinion, that's way too wordy. Just look at the picture. Sine of theta is when you have an angle centered at the origin, its terminal ray right here. Look where theta is located. It creates this triangle. If I draw a line from point P down to the axis, I get this right triangle. So I want you in your picture to put a little right angle symbol there. This is why I gave you that extra credit opportunity. Everything is built on right triangles. If you'll notice, the radius of the circle is the hypotenuse of that triangle. And the way that he labeled it, see where he put x? It's the horizontal distance from the y-axis over to P. You could think of x as also being this leg of the triangle down here. That works the same, okay? So in my opinion, if you understand that there's a triangle there, look at what sine theta is. It's just y over r. It's y over the radius. And in the picture, you can see that the radius of the circle from the center out to an edge, okay, that's just the hypotenuse of that right triangle. So sine of the angle is equal to y over r. Cosine of theta, if you're ever asked to find cosine of an angle, that's always going to be the ratio, aka fraction, of the horizontal displacement, in other words, x, to the, that just means radius. So cosine of theta is x over radius. And then tangent is the slope of the terminal ray. That's going to become really important for you in one of the problems that we do in our notes today and on a test question. That tangent of theta is just the slope of the terminal ray. It's the ratio of vertical to horizontal. So look at your formulas there. Tangent theta is just the y distance over the x distance. Tangent is therefore equal to sine over cosine. That's basically all the information I'm going to give you today, and now we're just going to practice it. So turn the page. Example 1. So a lot of your test questions are going to have pictures like this. Some of them are not. They're just going to give you a bunch of words, and you would probably benefit from drawing the picture yourself. So let's see what all kinds of vocabulary they use here. The figure shows a circle centered at the origin with an angle of measure theta in standard position. You can see that in the picture. The terminal ray of the angle intersects the circle at point P. So here, when they're talking about terminal ray of the angle, they're talking about this, the hypotenuse of that triangle, which is R. The coordinates of P are positive x, positive y. Which of the following is true about cosine of theta? Well, on the previous page, and really all you're going to be practicing today are those definitions on page 1. Cosine, by definition, is x over r. What's the radius of this circle? You've got to figure that out in the picture. Can you look at the picture and tell me what the radius of the circle is? 3, because this point out here on the edge of the circle is at 3, 0, so radius is 3. And what you'll see me typically do throughout this chapter is I'll just kind of immediately write down what the radius is out to the side. Well, if cosine is x over radius, then cosine of this angle in the picture right here is going to be x over 3. And the only answer choice that has that is A. But go ahead, it'll benefit you to go ahead and read the rest of it. The justification is because it's the ratio of the horizontal displacement, that's x, over the distance between the origin and P, that's r. So it's x over r. But you have to know all of that fancy wording for the AP exam. Horizontal displacement over radius. Okay, let's move on. That's it on example 1. Example 2, we've got this picture now. The figure shows a circle with radius of 5. I'll go ahead and just write that down. The radius is 5. It's centered at the origin. An angle of measure theta is in standard position. The terminal ray of the angle intersects the circle at point P. So now, watch what I do with my pen. We've started at the x-axis and we've gone all the way around. And this terminal ray, intersects the circle at point P. Find the following values: sine of theta, cosine of theta, tangent of theta. Now there's something in the picture that we really need that we haven't addressed yet. It gives this point up here in quadrant 1 as 3, 4. What does that mean the ordered pair for P must be? It's our positive negative quadrant. So we're still positive in the x direction, 3. And you could even label it like this. Okay, everything is based on triangles essentially in this unit. So this is 3. And then the y distance down to P has to be negative. Now, it told me that the radius was 5, but I want you to put your thinking caps on for a second. If you have a right triangle and the legs are 3 and 4, what must the hypotenuse be? It's a Pythagorean triple. 3, 4, 3, 4, 5. Okay, so I'm going to say that again because I'm not sure that we knew that. You're going to need to know your Pythagorean triples on the test. If your legs are 3 and 4, your hypotenuse is always 5. Now, technically, out to the side, you could do a squared plus b squared equals c squared, do all the work, and you would get 5. They were nice enough to just go ahead and tell us, hey, the radius is 5. So put this on your triangle. 3 is in the positive direction. I know it feels weird, but I want you to label this y distance here as -4. And then the radius there is 5. So when we're trying to find sine of theta, on page 1, what does it say? How do we set up our fraction for sine? Y over radius. Y over r. And in our picture, what is y? Yeah, you can either get it here, hey, the y distance is -4, or you can get it off the ordered pair for p. That's the y value of p. So -4, the radius is 5. So sine of theta is just simply -4/5. Cosine of this angle has everything to do with the ordered pair, where the terminal ray intersects the angle. Okay, so if we're trying to find sine or cosine or tangent of an angle, it has everything to do with the ordered pair of where that intersects the circle. Cosine of theta on page 1 says x over r. Well, the x of the ordered pair is 3, and the radius is 5. So cosine of that angle in the picture, theta, is 3/5. That's the value of cosine of the angle. Tangent is just x over y. Well, x is 3. Oops, sorry, did I do that wrong? It's y over x. Where is my white out? Ah. Y over x. And in our picture, y is -4, x is 3. So tangent of the angle in our picture is -4/3. You're just practicing with those ratios today. See how much we can get done before the lunch bell rings, and then we'll finish it up. This is already the last page of notes. We're almost done. The figure shows a circle with radius r centered at the origin with an angle of measure theta and standard position. So just look at the picture. Do we know what the radius is on this problem? No, it just says r, 0. The terminal ray of the angle intersects the circle at point P. The coordinates of P are x, y. All of that's labeled for you already. The points Q, R, and S are a result of basically a bunch of reflections. So if P is called x, y, what could we label Q as? -xy. Very good. And there's a place for you to write that down here. -xy. Point R is down there in quadrant 3. What are we going to call R? -x, y. And point S is in quadrant 4. What are we going to call point S? +x, y. Very good. You might want to label those in your picture. It'll probably be helpful. Let's see how the questions are being asked. It says, find the sine of the angle whose terminal ray intersects the circle at point S. So, in other words, we care about point S. We don't really care about any of the other points. We care about this x, -y. And it says to find sine of that angle. And when you're writing theta, you can just draw a little oval with a line through the middle. Sine of theta. Well, by definition, sine of theta is y over r. And we don't know the radius, but we do know the y value of point S is negative y over radius, which we're just going to call r. That's it. We're just practicing with the ratios, setting up the fractions. Find the cosine of the angle whose terminal ray intersects the circle at point Q. So now I only care about point Q, negative x comma y. How do we set up the fraction for cosine of an angle? X over radius. Well, the x value for point Q is negative x, so negative x over r. Oops, I guess it's technically not the last page of notes. Find the tangent of the angle whose terminal ray intersects the circle at point R. So we only care about point R, and tangent is y over x. Well, point R is negative y over negative x, which is positive. Negative over negative is positive, y over x. So we're going to start talking about things like which quadrant will tangent always be positive in, which quadrants will sine be negative in, and so forth when we get to the next lesson. When we get back from lunch, we'll knock out this on the very last page of the notes. We'll do that problem, and then we're done. Don't worry, it's not like we have to fill all of this space with our work or anything, but we are going to draw a picture, which is why I kind of left this whole space for you to use if you need it. But it says, let theta be an angle in standard position whose terminal ray coincides with this line. Typically, the problems that we've been looking at, we've just been looking at the ordered pair. So it coincides with this line, and it tells us in quadrant 2. Find the following values. So here's what I want you to do to the best of your ability. I want you to draw an x and a y axis. And I want you to draw an angle in standard position, which means it's going to start on the x-axis. And it's going to coincide, the terminal ray is going to coincide with y equals negative 3x. Well, if you think y equals mx plus b, what is the slope of this line? Negative 3 is the slope of the line. And it's in quadrant 2. So it's going to be somewhere-ish, like right there. The slope is negative 3. Now we're supposed to find, this is theta. It's going to be that angle measure right there. So when it says coincides with the line, it just basically means it is, that terminal ray is on the line, okay? Now let's add a little bit more to our picture to make this really easy. Because I worked it a really difficult way, and then I found kind of an easier way. Let's draw a triangle down to the x-axis. If we know the slope is negative 3, slope is rise over run. And look at this triangle. Is the rise positive or negative? The rise is above the x-axis. So positive 3. And then the x value is in the negative direction, so that's negative 1. Rise over run, that's where we're getting a slope of negative 1/3. Now I want you all to solve for r. In other words, I want you to take this right triangle, and you know a is negative 1 and b is 3, and I want you to find c. A squared plus b squared equals c squared. And you don't have a calculator, so you're just going to have to leave it in terms of a radical. So let's say negative 1 squared plus 3 squared equals c squared. That's 1 plus 9 equals c squared. That's 10 equals c squared. So the radius is going to be the square root of 10. And I don't want those of you that are like, well, shouldn't it be positive or negative square root of 10? Technically, yes, when you're solving an equation for a variable and you're taking a square root, it should be positive or negative. But for now, I don't want you to worry about that. Just consider in this picture right here, the radius is positive root 10. So here's x, here's y, here's r. We have everything we need to answer these really quickly, and then we're done. Find sine theta. Well, you just went to lunch and came back. Do you remember what the little ratio is for sine? Is it y over r or x over r? It's y over r. And what's y in this picture? 3. And what's the radius? Root 10. If you've already done my extra credit, you know that you can't have a radical in the denominator. How do we get rid of root 10 in the bottom of the fraction? Multiply by another root 10. And what you do to the bottom of the fraction, you do to the top, just to keep it even. And I'm just going to work down the page because I'm out of room to work horizontally here. But what's going to happen there is you're going to have 3 root 10 on the top. That's 3 times square root of 10. And on the bottom, the whole reason we did this is because the square root of 10 times itself is just 10. I want you to know what you just found. You just found sine of this angle. That may not mean a whole lot to you right now, but it's really important that you understand that's what you found. We're going to do cosine theta. And so the ratio there is the horizontal distance. The horizontal distance over the radius. So that's going to be negative 1 root over root 10. And we're going to fix that. It's called rationalizing the denominator. So that's going to be negative root 10 over 10. Notice cosine of theta that terminates in quadrant 2 is negative. Sine of theta that terminates in quadrant 2 is positive. I'm going to talk about that on Friday as well. I think tangent ends up being the easiest one of all. Because if you will look back to page 1, it says right here, we could set up a fraction and do a bunch of crazy math stuff. We could. Or if you know that tangent is the slope of the terminal ray, that's this right here. This is the terminal ray. What's the slope of this line again? It's just right there in front of us. It's negative 3. Tangent of theta is negative 3, period. Boom. That's the slope of the line. The slope of that ray is, by definition, tangent of the ray. That is way easier than the math that you'll see that I did in the notes on Schoology, okay? And my first period kids have to teach themselves this lesson.